So welcome to the BinaryEdge Videocast. One of the things we usually do inside as a team is we share a lot of links and news, interesting things we've read or interesting things that we're doing with the rest of the team. This time around, we thought it would actually be interesting to share some of these things with you guys on the outside of BinaryEdge. So we tried to find what's the best format to share this information, and we thought small videocasts would be an interesting format. There are some rules to our videocasts. Each week, you'll have 2 or 3 members of our team talking. Each member gets about 5 minutes to talk, maximum. Sometimes we will have guests, or we'll do different types of videocasts and we'll break from that content, but as a general rule, everyone will have 5 minutes to talk. After this episode is released, we will make sure we put all the materials we've presented today, such as papers, pieces of code that we've written, on a public repo so that you guys can also test some of the things we've shown on this videocast. This is all very informal. It's as if we were having an internal meeting. There won't be any heavy editing, so make sure you enjoy it. So I'm actually the first one. I wanted to share a couple of things I've been looking at this week with you guys. So if I could just go here. So screen share. All right, so if you guys can see my screen now. Cool. So there's been a couple of interesting things done this week. One guy wrote a small blog post about hacking QNX systems. QNX systems are systems that are found in cars as entertainment, where you can play your MP3s, you can look at GPS, things like that. These are things that essentially are found in cars. And he found out that there's some service on port 8000 that's fully open. He actually mentioned here that he looked on Shodan if there was anything open on Shodan, but that he couldn't find anything. I think the guy from Shodan actually replied to him afterwards that there were a few in there, but I thought it would be cool to see, yesterday how many were connected to the internet. So let me show you here a little bit my console. If you just give me a second. Here. So what you're looking here is 2 of the jobs I did yesterday. So the first thing I'll do here, obviously, I'll look at all the different files. So essentially, when we do a job on our platform, as you guys know, we receive multiple files. So what I'll do is I'll go and look for the QCon, which is the service that's running on that port. And as you can see, there are actually quite a few of these things connected directly to the internet. Well, actually, I made a mistake. Typo. QCon. So we'll wait a little bit just to see here. But as you can see, it starts to find a couple of these things connected directly to the internet. So this is quite interesting, as there must be the possibility of it being an actual entertainment system connected to the internet, or maybe just one of the developers actually has this thing connected and is doing development while this service is fully open. The interesting thing about this is that you can actually connect to this service and execute commands on the remote system without any type of authentication. In total, I believe I actually found 28 of these connected to the internet, so it's still a good number for what is probably something that can be quite critical. The other thing I wanted to show you guys, if you just give me a second, I'll switch here. Switch share. The other thing I wanted to show you is this thing. So this guy is actually pretty cool. He's been doing some really nice research. Shout out to Mainframes 767. He does research on finding mainframes on the internet. So mainframes are big old ass computers that are still connected to the internet. They're really legacy, really old systems. And we actually traded a couple of tweets a while ago. about one world scan that he was doing, trying to find mainframes on the internet. He has a really cool Tumblr project as well, where he essentially scans the internet for mainframes and then posts the screenshots onto this Tumblr. So there's things like old mainframes from DARPA, from the US government, from the Pentagon. I know he's posted quite a few things online. So, US government information system, all of these things. And I thought, again, that I would do a scan to see, what was really the number of mainframes still connected to the internet. So our scan obviously returns lots of different systems. I focused specifically on the port 902, which is the port where, this guy has been doing his scans, as he shows here on his Tumblr, port 992. And essentially what I found is what you can see here. There's still quite a bit of mainframes connected to the internet. So these are really old legacy systems that are still connected online. 1095 IBM OS 400 and Telnet more on top of that. And even older, it's the 390s, and there's still at least 4 of them that we found connected to the internet. So this is the 2 interesting things I found. It's more from a security perspective. 2 of the interesting things I've read this week that I thought were pretty cool, and I thought I would check up on the internet what is still online, what is still connected. That's it from my side. So I'll now pass over to Filipa. She has some really interesting stuff to show you guys, and Filipa.
Hi guys, so today I am going to talk about face detection. So a few weeks ago, as you know, I had a test consisted of detecting human faces in images, and after some research, I learned that most modern algorithms are based on this Viola-Jones object detection framework. And I found it very interesting because their work was originally published in 2001, so more than a decade ago, and yet still very popular. Of course, nowadays we have other popular algorithms for object detection, such as deep learning, but I chose to present the Viola-Jones framework because it's fairly simple to use, it's available on openCV, it's fast, and generally it works very well. So the paper, I'm going to share my screen. So the paper is this one, entitled Rapid Object Detection Using a Boost Cascade of Simple Features. I'm going to start by presenting some of the most important contributions and how it works, but at a very, very superficial level. So in order to understand the details and to be amazed at how clever this framework is, I strongly recommend reading the full article. Their framework can be used to detect any type of objects, but they were primarily motivated by detecting faces. I'll try to explain in a very, very simple way. So first of all, they do not use pixels as features. They use something called RR-like features, which are, let me zoom in here, so which are this type of rectangles. So when we are trying to find an object on an image, one approach is to find edges. And we can do this by finding an area that is lighter or darker than other area. And they use this approach. So they start by picking a scale for a feature, in this case, a scale for this rectangle, and slide it across the image. And what they do is to sum the pixels of the image which lie within this white rectangle and sum all the pixels of the image that lie within this red rectangle. And if the difference of these 2 sides is some threshold, we know that particular feature matches the data that is underneath. Here's a practical example of this works. So here we have a face, and we see that two features are matching some part of the face. So here we can see that the eyes region is darker than the cheeks, and here that the region of the nose is lighter than the eyes. So these 2 features are describing part of the face, but of course they are not enough to describe the whole face. So we need a lot of them, and also with different scales, because the face can have any size, and again sliding across all the image because the face can be anywhere. Therefore, these RR-like features are organized in something called a classifier, a cascade. well, this classifier Cascade is a series of R-like features in a particular order, so here, that have been trained. So if all the features match, it has a high probability of being a face. And here's some faces that they use to train their classifier. So as you can see, they are all frontal upright face images. They used about 5,000 images containing faces. And also they use about 9,500 images containing no faces for training. And well, as you can imagine, computing these features can be very, very computationally expensive. So they came up with a very clever idea to calculate these features. So here, so instead of calculating all these features, they create an integral image which consists on pre-computing the sum of all regions in an image. And once this sum has been computed, the task of evaluating the intensities of any rectangle requires only 4 array references. So it is a very clever solution. And that's it. I won't bother you anymore with more theoretical stuff. So now I'm going to show you in a practical example how to use the Viola-Jones framework implemented on openCV in Python. So first, you just need to import the openCV in CV2. And I'm also importing the Pilo library because I want to save the image and display it on the notebook. Here is the function that I'm using to detect the face. So first of all, we load the image in the grayscale because the Viola-Jones framework works better in the grayscale. And then we are loading this XML file that contains all the pre-trained faces. In this case, I'm using the frontal faces. We also have available other XML files containing the eyes, the smile, and others. But since my goal is to detect frontal faces in my images, I'm using this XML file. And then we apply this classifier into our image, and as you can see, there are a bunch of parameters that must be tuned in order to deliver the best results possible. I won't explain how they mean because, well, this is a little bit complex right now, but you can read the openCV documentation along with the Viola-Jones paper in order to understand details and choose the best values for your case, because the results will strongly depend on these parameters and also on the image that you have. So if faces are found, it will return the positions of that face in the image. And with that, we can use these locations in order to create some square around the face so we can see where the algorithm found the face. And let's try with a completely random image with a single face. So let's see. Oh, I have to run this. So let's see. And so we have this image containing a beautiful face. So let's run our classifier for this image and also run the box function to create the box around the face if it detected. So let's see the result. And it worked. So, and I don't know if you noticed, but it was really, really fast. So let's try again for an image containing multiple faces. Again, a completely random image. So we have again an image containing 4 not so beautiful faces. Let's try with our classifier. Let's see if, and it worked. So a really useful application of this type of face detectors for BinaryEdge is to detect faces on the VNC and RDP images that we collect. Because we collect thousands and thousands of these images, it's nearly impossible to check one by one looking for relevant information. So one thing we do is we can select the VNC and RDP images that contain faces, so contain relevant information and sensitive information. I'll show you a real example of one of the images that we discovered. So RDP. So let's see. So here we have a locked screen of Windows 10, and we see a profile picture here, and again the same profile picture but smaller. And of course we cover the email and the name for obvious reasons. Let's test our classifier. And it worked, and as you can see, it detects the two faces that have different sizes. So this is a very, very powerful algorithm and usually works very, very well. You only have to optimize these parameters, and for that, I would recommend you to read the paper and also the openCV documentation, but it's a very, very simple approach. And that's it.
All right, that was actually really nice. So as Filipa mentioned, some of the things we do at BinaryEdge, we have a platform that looks at the entire internet, and every time we find either an HTTP service or VNC or RDP, we take a screenshot of that. And then out of those screenshots, we extract different types of information like faces. We also extract logos, so it allows us to classify things if it's a SCADA or if it's a critical system or not. We use all of these techniques from machine learning and data science to help us categorize those images that we acquire. I'll now pass over to Joao.
I'm Joao, I'm a developer, and one of my main concerns is usually clean code. And what is clean code? Well, clean code is code that is easy to extend and to test. So when I was learning Go, this is the Go programming language, one of my first tryouts, the first thing I tried to do with the language was to write a simple API. In the old days, you would learn just how to write hello world. These days, you start by writing a small API that connects to some service or some server. And this is the typical hello world. So we have here our main, which is the first function that is run in Go. And as you can see, we create a router. We call something called the handler function, where we define the URL. So in this case, any request that goes to /foo in our API goes to this handler. Now, as you can see, this handler is a function. So if I have something inside of here that I need to change, well, I need to change it here. And if I have another route or something else that uses a service, well, I need to change it here. And if I only have one implementation, this becomes a bit tricky because it means that the service, in this case, I'm representing my service as this getData function. As a service, it will be coupled with this route. So every time I change either getData or this handler function, they will be coupled, which means that I can change one without changing the other, or at least it will always affect the other. So one other way of doing this is, instead of using a handler function, which is just putting the function here, is to use what's called in Go a handler, an HTTP handler, which is similar, but it has differences. For example, here I have not here. So here I have a very similar, it's like the next iteration. I implemented the bar URL, and here I'm passing the bar handler. What is the bar handler? Well, it's a struct that implements what is called the HTTP handler function, which is closer to the other one, but as you can see, now this belongs to an object, to a struct. So if I need to change what I need to do inside of bar or any request, I just need to change it inside of this function. One other thing that is similar to the other one is, as you can see here, when I declare the handle, I declare a method here. I call this methods and say get. I can't do that in this version. In this version, I have to check if this request object is a get, a post, something else. So by having this handler struct or object, I can define for each route a specific behavior, and I don't have to have a direct coupling between any service that I use with the route. But as you see, I still just call getData here. I'm not getting this getData from anywhere. So if I need to test this, I can change the implementation, which means if I have a route that connects to another service, it will try to connect. And if it has the default configuration, or for example, if you have in your code the URL for a production service, it will try to connect to it. So there's still no way of changing during testing where it will connect or what it uses, because I just have it hard-coded here. So Go has a concept which is closer to an interface, to a struct, which is an interface. An interface, I don't have it here. So an interface is a different type of object. It just says that this object, whatever it is, implements an interface. So we'll introduce here an interface, which is called SomeInterface, and it implements this getData function. This getData function just returns the string, doesn't say anything else about this. So what we can do is we can say that this bar handler implements the SomeInterface. What does it mean? It means that this handler will have something. It can be an object. It can just be this pass a function to it, and it will know how to deal with this getData function. So in this case, if I create my bar handler with some object, let's call it a service, that knows how to implement the service, then I can just say that my handler will know how to handle this. And this way, when I create some tests for this, I can actually say, here's an implementation of some service, and it will do whatever it is. Since it will be a test, we probably won't have it connect to a production service. We'll just have it return true or false, or an empty string, or a string with a name. Depends on the test. But this way, we can actually do actual encapsulation, which is one of those concepts we learn in college, but we think are never useful. This is the kind of example that I was looking for when I started learning Go, because I had no idea how to structure this. I knew about the structs, I knew about interfaces, but I had never seen. And if you search online, you will find like 20 different ways of doing this. Some are good, some are bad, some depend on actual other libraries for testing. They will tell you, oh, you have to inject a mock or create a stub or something else. But none of the solutions that I saw when I was learning, and I haven't searched a lot since then, so I didn't see any solution that was really just simple and used features from the language to actually help writing tests. Because right now, the way that the bar handler works, I can just pass it a service. So this is the kind of tutorial I was always searching online. There are a couple of screencasts and podcasts that will teach you Go with small examples, but I never quite saw one that would actually explain this, and in a way that you can have good, simple code. Of course, you have everything here in the same file, but please don't do this. This is just for a demo. If you do this in your company, someone will come over and smack you and tell you to split the code into several files, because that's just being nice to the other developers. Because if you put everything in the same file, well, I will find you and I will make you suffer, because you really shouldn't do that. Well, this is what I wanted to show everyone, because I think it's one of those simple things that you can learn in like 5 minutes.
So I've got some questions. Well, not questions, more, bit of a discussion. You've been working with Go now for about 6-7 months with us.
Yep.
I know you used to code before JavaScript, Node, Ruby on Rails, all of that. So how are you finding the transition between those languages into Go?
That's an interesting question, because you hear everywhere that if you know Ruby or if you know JavaScript, you learn Go. Well, Go is a really easy language to learn, it has, like Python, a huge standard library. So you have you can create APIs with
Oops, João disappeared. Okay. Until João recovers, I guess Anna will pass over. João, are you back?
Yeah.
Yeah, there you go. You stopped there for a second.
Okay. There are some concepts in the language that take some time to figure out how to use.
Yep.
Like Go routines, they are easy to use. They should be used. They shouldn't be used lightly, because you can have Go threads leaking, which means that you have something running in the background that you don't want. Like you can have something that's still connected to some service, and it should be off, for example. There are some also really good libraries to help you deal with that in the sync package. It also has a lot of funny things like mutexes, read-write blocks, lots of fun things that you can learn how to use. It's actually really fun language to use, but there are some corners that are a bit annoying, like always doing functions that have to return an error to know if it failed or not. Instead of, for example, we have here a function that returns a string. It could, if it was an actual service, it could return a string and an error and say if it actually failed or not. So that part of the language is a bit weird and sometimes annoying, because it gets duplicated everywhere.
So my last question is, if you had to give two references for someone that wants to learn Go, what would they be? And the two references as in one for a person that is a beginner in programming or just wants to take on Go, and another reference for someone that has been a programmer before and is transitioning into Go, what would those references be? Where should I start?
Well, since I'm a bit of a language nerd, I recommend exercism.io. I will link it. It's a great website for learning language. It has, if I'm not mistaken, like 24 languages with several problems, from kind of hello world kind of exercises to more advanced ones. And of course, the Tour of Go, which is in the main page of
official website.
The official website. It has really small lessons. You can learn them after school, after work. They're really small lessons, and it's enough. They both work for those two types of programmer.
All right. Thank you very much, João. I will now pass over to Anna.
Hi, everyone. So today I'm going to talk about R versus Python. I know there are a lot of articles out there. But this is a topic that is quite discussed at BinaryEdge, actually, because I'm the only one that uses R in a daily basis. So since I've been using both actually in the last couple of months, I thought it would be interesting to share my experience with you. So I'll start by sharing my screen. Okay, so first I should start by saying that I don't have a background in computer science. My background is pharmaceutical sciences, and I had never programmed until a few months ago. So I started with Python and soon gave up. I don't know if I had the wrong approach, or maybe at the time I didn't put in the effort needed. So I gave up easily. And after that, I went and tried R. I started learning R by doing some exercises and watching some videos in DataCamp, which I highly recommend for someone that needs or wants to learn R. I got used to the language quite fast and soon put it to use with internal data, BinaryEdge's data. And that's when all the problems came to me. So I don't know if you know BinaryEdge or what we do, but we have huge amount of data coming to us daily. And R is not made to use this amount of data. So that's why they created Spark R. And I tried to use it because our studio was always crashing with our data. So I tried Spark R, but the project was in a very early stage at the time, so there weren't lots of documents regarding its use, and it was a no-go for me. I couldn't make it to use for us at the time. So I had to go back and learn Python. And the second time around, it was much easier, maybe because I already knew R, or the effort was different because I really needed at the time. Yeah, so it's comparing both languages, and I used both at the time. I found R really easier to learn for someone without a background in computer science. However, it doesn't have as many documents and forums for questions and everything as Python. I've read in many websites and some articles that the learning curve is really difficult for R, but I don't know, maybe if I knew another language before, maybe the transition would be difficult because of the syntax. I heard a lot of people say that our syntax is unconventional and ugly, but for me it's still easier than Python. I've been enjoying working in Python. It handles a great amount of data really well. However, for me, the data frame thing in R, it's much easier, and it takes really less time to code. However, in Python, after the code is written, it runs really fast. So, as I said, now I'm using both. And I think for someone starting in data science or working with data in a daily basis, it's important to know both for different reasons. They are good at different things. And I've mentioned already the difference in syntax. I don't know, I still feel more comfortable with R, maybe because it was the first language I learned, but I'm fairly comfortable with both at the time. So that's it.
So I'll ask the same question I asked Joao. So if you had to give, for new data scientists, a reference in terms of learning R and learning Python, what would you recommend?
I'm a big fan of DataCamp. I learned both Python and R in DataCamp, and they are amazing with the videos and even the exercises. It's really good. It's really helpful. I've heard that there are some good courses in Coursera as well. I've never tried them, but yeah.
Okay.
That is my recommendation.
So that's it for us. Thank you very much for watching. If you guys have any questions, we will be able to answer them on the next episode. Feel free to send them to info@binaryedge.io. That's EINFO@binaryedge.io. And we'll make sure that we reply to your questions on the next episode. Thank you very much for watching. Thank you, team.